Okay, so we're going to be looking to find the zeros, aka x-intercepts, aka the roots, all right? And then we're going to state the multiplicity. So we're going to say, okay, it has multiplicity of 1, multiplicity of 2. Is that odd? Is that even? All right. In order to do that, the first thing we would have to do is change f of x into 0, because that's the only way that we can really apply the zero product property. There's nothing else on the left side. We know that f of x is the same thing as y. So all we need to do is change that to 0 so that we can solve. So we get 0 is equal to x times x minus 1 squared times x plus 2 squared. Okay. When we're here, remember that we're allowed to basically split this up into the amount of equations that we need. So real quick, I know that the first one and the one that always seems kind of strange is, this is my first factor. It's just x, right? I can set x equal to 0. And even though I don't have to do any work to it, this one tells me one of my solutions, right? So I have a root, or I have an x-intercept when x is equal to 0, right? Along the x-axis, when x is 0, there's a root there. Okay. Then I have, right, so that's one. The next one would be this one, x minus 1 squared equals 0. Well, x minus 1 squared is the same thing as saying x minus 1 times x minus 1. So if I were to solve this, right, this is like saying x minus 1 times x minus 1 is equal to 0. But that's the same solution twice. You can see that, right? You can see how that becomes x minus 1 equals 0, x minus 1 equals 0. Sorry. And eventually this is just x equals 1. But it shows up twice, right? The same solution shows up twice. So this is something that we would often maybe say double root. But in this case, we're not going to say double root. We're going to say multiplicity of 2. Right? It's a multiplicity of 2 because the solution is showing up twice. Right? If the solution would have shown up 3 times, then we would have said multiplicity of 3. Okay. So what do we know about x equals 1? That means it's a multiplicity of 2. What is 2? 2 is even, right? So we have even multiplicity at x equals 1. So at x equals 1, if we were drawing a graph, would we cross the x-axis at 1, or would it bounce off? Yeah, it's going to bounce, right? It's going to hit 1 on the x-axis and then do one of these, right? Just bounce, okay? Versus at 0, at x equals 0, what kind of multiplicity do we have there? It's a multiplicity of, how many times do we get the solution x equals 0? Just once, right? That solution only showed up once, yeah. So we can say multiplicity of 1. If it's multiplicity of 1, what kind of multiplicity is that? Odd or even? That's odd, correct. So then we know that when it hits the x-axis at 0, is it going to bounce off at 0, or is it just going to pass right through? Is it going to cross the x-axis? It's going to cross, right? So we have a couple different things going on at different intercepts. On some intercepts, it crosses. On some, it just bounces. So that's where you create these kind of intricate polynomials. So that's where we need to start. We start by identifying multiplicities. Now we can kind of paint a picture like, okay, it's crossing here, bouncing here. But I still have one more solution that I need to identify and identify the multiplicity of it. All right, take a look at this last one where we have x plus 2. Notice how that one also has a power of 2. So what it's saying, it's x plus 2 times x plus 2. That's equal to 0. So we know we're going to get x plus 2 equal to 0. X equals negative 2. How should I label this in regards to multiplicity? There you go, right? Because we had this solution was going to show up twice, right? You can tell by the power. right? It's a power of 2, so the same term shows up twice, and a solution shows up twice. So this also ends up being a multiplicity of 2. Okay. And that's essentially all we're going to do for today, right? It's just find the solutions and then give the multiplicity of them. Okay. Any questions there for example number 1? This what I have in front of me pretty much, right? Like I know it's a lot to box, but you have your first solution, the multiplicity of it, multiplicity of 1. You have your second solution with a multiplicity of 2, so we know that that's even. And then the last one is x equals -2. This is a multiplicity of 2. Right, so at those x values, at those points, we know what the multiplicity is of each. So if we wanted to start graphing, we could. We're not going to go there yet because we're going to continue to work on finding these zeros and then stating multiplicities. All right. Any questions before we move on to the next one? So essentially, yes. You probably wouldn't be asked what is the multiplicity of blank. You would be asked like graph this polynomial, and then you would begin with f of x with what you have, and you would have to go through this whole process. So you would begin by first finding your solutions, stating the multiplicities, because it leads to something bigger, right? This is only like the halfway point, but we're just practicing this for now. The second half we'll do on Thursday. But you would need to know the solution first. So if they ask like, what's the multiplicity at x equals 1? You have to be able to know that, hey, this is the same solution happening twice. So I would say multiplicity of 2. If that was the question, if it was just a very straight up question. Okay, I labeled it as even, but technically the correct way to write it is it's a multiplicity of 2. Okay, let's move on to the next one. All right, we have for the following polynomial, once again, find the zeros, state the multiplicities. All right. The other reason why they call it like find the zeros is because when you're looking to solve, what is it that you have to turn this into? You have to turn it to 0, right? So you're finding the x value that converts the whole function into or equals to 0. Okay, so we begin with a familiar process. All right, and then this is where you need to apply everything you learned about factoring. If you were given a polynomial like this, and you knew that your first step is to turn it into 0, then what would you do next in order to try to factor the rest of the polynomial? Yeah, we could start by factoring out x, right? You see there's a GCF there that they all share. They can both all be divided by x. So we begin with that. Divide by x. That should leave you with x squared plus x minus 2. Okay, so now we bring down equals to 0. All right. But before you decide, hey, I'm going to split it right now and try to find solutions, you're looking for 3, right? You're looking for 3 solutions. You have x as one factor, and then you have the trinomial as another factor. What do you think you need to try to do one more time? Because ideally, you'll get to a point where you see 3 separate factors. Right now, I only see 2 factors, the x times the trinomial. What do we need to attempt to do with the trinomial? Yeah, we gotta factor it. You can try to do Xbox or you can use whatever method. At this point, we're not gonna spend time on like, okay, what method, go through that whole process, right? We're just gonna say like, all right, we need to factor that, right? In whatever way is best or fastest. So I know that this is still X. I can see that these factors are gonna be X plus 2 and X minus 1, right? And you can double check, you can confirm that for me. But I can see real quick that in order to get X squared, it's just X times X. In order to get -2, it's 2 times -1. And I can do a little bit of mental math here and see that 2x minus 1x is positive 1x, which is what I'm looking for. Okay, so a lot of times these won't be too complex. The factoring can be done fairly quickly. All right. So you see, I started off with a polynomial that was to the degree or the degree of 3 or third degree polynomial, which ultimately tells me, hey, I need 3 solutions, right? I need 3 solutions. So hopefully I get to the point where I'm able to factor it into 3 separate factors, and then I can split it using the zero product property. Now I'm at the point where I can say, okay, let's break it into 3. The first one would be x equals 0. It seems strange, right? Because it's like, okay, is that it? Are we done? Yeah, we're done. That's it. We have a solution where x is equal to 0. We have another one. X plus 2 is equal to 0. This time, x plus 2 has no power, right? This is just x plus 2 once. So when I solve, this is just x equals -2. And then when I solve this one, same idea, right? The power up here, there is none. It's just x minus 1. There's only one of those factors there. So when I solve it, I get x equals 1. So now I have them. When I go back and I label their multiplicities, all right, x equals 0 has a multiplicity of, how many times does that solution show up for us? Yeah, just once. So it's a multiplicity of 1. So what do we know is going to happen with the graph at that x value? It's going to cross. There you go, right? It's going to pass right through the x-axis. Okay, then we get to x equals -2. How many times did that solution show up for us? Only once, right? Once again, this is only once, so it's another multiplicity of 1. So at 0, you can kind of picture it. Like, okay, at -2, it crosses. At 0 on the x-axis, it crosses. And then we get over here to where we have x equals 1. Once again, this should be labeled with a multiplicity of just 1, right? Because the solution only shows up once, right? It has nothing to do with what the answer is. It's just how many times did the answer show up. So since x equals 1 only shows up once, it's a multiplicity of 1. So this polynomial, we can kind of imagine that at 3 different points on the x-axis, it crosses, right? So it probably creates this kind of like zigzag shape. First, it crosses at -2. It must have turned around because then it has to cross at 0. And then it must have turned around and now it's going to cross at +1. That's what we're going to do next time, right? But you can see how once I have the points where these graph is going to cross, the rest is, there's other methods, but the rest is just like, okay, now I just have to figure out like what's happening in between, right? So we're kind of building towards that part. All right. Any questions here? All right. And then we get to the last one. The last one, we got to do a little more factoring. All right. So same idea. Fact for the polynomial f of x, find the zeros or find the x-intercepts and state their multiplicities. So if I have f of x is equal to 2x to the fourth minus 8x squared. Yeah, I know that this, first of all, right, I need to have this equal to 0. So before I do a GCF, right, change that to 0. And now I can apply GCF, right? You can see how they both can be divided by 2, and they could both be divided by x squared. So We factor out 2x squared. And what's left? Yeah, we should get x squared minus 4. Okay, so technically I'm looking for about 4 solutions. That could also include the multiplicities. All right, so including certain solutions that show up twice, it's a total of four solutions. All right, now I see something here that is not done, that needs to be factored further. What would you call x squared minus 4? What name would you give that type of expression? It's a difference of squares, that's right, right? So difference of squares are pretty easy to factor. We should be really familiar with them now. This factors into x plus 2 times x minus 2. And then I can bring down the GCF, and then this is equal to 0. So now I'm at the point where even though I don't have 4 factors, even though I don't have 4 separate factors, I do have 3 factors. And I notice that this one has x power of 2. So it's likely that this one's going to carry that multiplicity of 2. So that's 2 solutions right there. And then another one for the third factor, and then another one for the fourth factor. So that's probably where my four solutions will come from. All right, so let's see. Start splitting it. All right, we have 2x squared is equal to 0. We have x plus 2 is equal to 0. And then you have x minus 2 equal to 0. When you're solving the first one, 2x squared equals 0, you're trying to get x by itself first. So you should divide both sides by 2. X squared equals 0. How do you solve for x? What do you do to both sides? Opposite of square. It's already squared right now. Square root. There you go. Right. So square root both sides. There you go. Because the 2 and the square root cancel. You end up with x is equal to square root of 0 is just 0. Okay, now this is where it gets kind of hard to see though. You see how it was a power of 2. Remember that typically when you square root something, typically it gives you like the positive and the negative of it. Well, there's no positive or negative 0, but what could we say about the multiplicity of 0 if the power that it was carrying at the beginning was a power of 2? Would x equals 0 have a multiplicity of 1, or would it have a multiplicity of 2? Yeah, it has a multiplicity of 2. A lot of times the power is indicating the multiplicity, right? How often that solution will show up. So this one is a tricky one, but this one has a multiplicity of 2. Right? Because I think you would agree that if I had x squared equals 0, that's the same thing as x times x equals 0. So the zero product property is built in here. Well, if I split this, that's x equals 0. The other one is x equals 0. So you see the solution shows up twice. It's harder to see it when you use the factoring method. But if I look at it slightly differently, well, that's the same x times x. And I can, because the zero product property still applies because x times x is a product, then I split it, x equals 0, x equals 0. So I think this kind of paints a better picture as to why we get a multiplicity of 2 with the solution x equals 0. Okay, any questions there for the first one? All right, so then the rest, fairly simple, right? We just have to solve for x. Here we get x equals negative 2. Here we get x equals positive 2. Here, right, these are different numbers. So this would be a multiplicity of 1. And the other one would also have a multiplicity of 1. So there are the solutions, the zeros or the roots, and in addition, we've labeled the multiplicities that they each have.